Alright, this video is for the last topic in your Chapter 8 notes. It's from the same section 8.3, but this is absolute value inequalities. We did equations, but we did not do the inequalities. So this video covers absolute value inequalities. So in your notebook, we finished our last set of notes starting on page 8. So wherever you finish these notes, turn to a clean set of pages. And on the left-hand side on a clean page, that's going to be page 9 of your notebook. There's going to be a review and a reflect. I know we didn't get a chance to talk about these in class. But page 9, the review, you're going to solve, graph, and state the solution interval. So there's 2 inequality sets to practice there. I'll post those solutions online. And then the reflection question, what 3 things do you plan to do to prepare for the Chapter 8 exam? Now, we've already taken the Chapter 8 exam, but think about what you did to study and if that was effective for you. And the next test will kind of talk about what can you do differently or the same to make sure you get the best grade possible. So pause the video now, write down everything for the review and the reflect, work the review questions on your own. I will scan and post those solutions in my math lab along with the others. Then you're going to turn to page 10 of your notebook. The next side, this is section 8.3, and about absolute value inequalities. So 8.3 has equations and inequalities. This is specifically about inequalities. And I'm going to work on clean paper here so I have plenty of space. So again, we're on page 10 of our notebook. It's section 8.3 in your textbook. Marker's dying on me. Here we go. Section 8.3 in your textbook on absolute value inequalities. So we're combining what we learned about absolute value equations about what we know and what we know about inequalities. If you have your ruler handy, it might help to just keep your notes nice and organized. Alright, absolute value inequalities. There's a good visual in your textbook. There's one in your beginning and intermediate algebra textbook on page 576. And there's another good visual in the college algebra book. I like this one better. On pages 162 through 163. You have full access to that college algebra book. We're not learning out of that one, but the visuals on that one is better. So if you go to these pages in the college algebra book, those are nicely done. This one's a little not as clear, but this one's very nicely color-coded. So similar to absolute value equations, similar to absolute value equations, absolute value inequalities have 2 possibilities. So if you remember with absolute value equations, we split it into the positive option and the negative option. We're going to do the same thing for absolute value inequalities. This time we're going to graph the answers on a number line like we practiced for inequalities. So graph the answers on a number line to determine, oops, missed an R there, determine the solution interval. Alright, so there's 2 types of absolute value inequalities. The first type is less than. So we're going to start by talking about less than absolute value inequalities. And then I cannot spell today. And then we will talk about greater than. So less than inequalities is when you have the absolute value of an expression. Remember, absolute value bars don't look like the number 1. Absolute value is either less than some number or less than or equal to some number. Whether it has a line underneath it or not doesn't matter. It just has the less than symbol. In either situation, we're talking about numbers that are positive. So when k is greater than 0, whatever that number is, it's positive. So again, for less than inequalities, less than inequalities are between the two values. Similar to compound inequalities that we talked about in class. So less than absolute value inequalities are between the two values. So again, in that college algebra chart, it shows a number line. Let me change colors here. It shows a number line. You have your two answers, whatever they are. I'm going to call them A and B just to be general. Whatever they are, the distance is less than those numbers. So to be less than, it's between. It's kind of like if this was your house and you wanted to be less than 5 miles away, you would be close to your house. And so the textbook does a really nice job explaining that less than are between two numbers. So for these inequalities, we're going to do the same thing we did for the other ones. We're going to have the inequality. And then if you want to kind of make a 3-column chart here, we're going to have the inequality. Then we're going to graph to get our solution interval. So if you want to make a 3-column chart, you have your inequality, your graph, and then what we call the solution interval. We'll use the rest of the page for some examples. So example 1 is nice and simple. If I have the absolute value of x is less than 5. The absolute value of x is less than 5. I know that we're going to have two options for what goes inside those absolute value bars. Inside those bars, x is either -5 or x is +5. Just like before, you either have the negative or the positive of the constant over here. That's what the k value is over here. So you either have a negative of that k or a positive of that k. On the graph, we're going to graph the two spots. So we have 0 in the middle, 5 over here, -5 over here. So those are kind of our two boundary points. And we know that less than is between those 2 points. So because there's no line underneath, we're going to use parentheses. They're going to face each other, and we're just going to have an interval between -5 and +5. So our solution interval goes from -5 to +5. So anytime the symbol is less than, you always connect between the two values. And if you want to write the word between, that might help too. Less than is always between. So let's try another example here. If I have the absolute value of 2x plus 1 in those absolute value bars is less than or equal to 7. So you have an expression inside the absolute value bars, less than or equal to some number. We're going to set this up again just like the equation. And so you have two options. The expression inside, 2x plus 1 is either equal to +7 or 2x plus 1 is equal to -7. You set that up just like the equations. You have your two options. Then you solve for x. Do this part a little faster. We should be good at solving for x. I get x equals 3. And I'm going to move the 1 over here. I get 2x equals -8. Divide by 2. And I get x equals -4. So on my graph, those are my two spots. 0's here, -4 is over here, 3 is over there. I know that my answer is going to be between those two spots. This time we're going to use brackets because it has the line underneath. So we'll use a bracket and a bracket. They're going to face each other and go between So whether it has a line underneath or not, if this says less than, you always go between the two answers you get. So my answer is going to be one continuous interval from -4 to +3 enclosed between each other. Let's do one more example of less than. I ran myself out of space, but hopefully you still have a little bit of space. So I'm just going to kind of extend my page here. So example 3, if I have the absolute value of 3x minus 2 enclosed in absolute value bars, and then plus 5 is less than 9. So just like in an equation, we're going to isolate the absolute value before we go to solve. So I'm going to move that 5 to the other side. It gives me the absolute value of 3x minus 2 is less than 4. That color's a little light. Let me get a better color. Again, I move that 5 before taking away the absolute value bars. So the absolute value bars are still there, and 9 minus 5 is 4. Then I treat this just like an equation, and I separate it into two options. I either have 3x minus 2 is equal to +4, or 3x minus 2 is equal to -4. Go ahead and solve each one of those. 3x could be equal to 6. So you should get x equals 2 for the positive option. I'm going to do the same thing here, add 2 to both sides. 3x equals -2, divide by 3, and x equals -2 over 3. And it's okay to get a fraction, but you get those two spots. You get those two spots. And with those two spots, we're going to graph those on the number line. I'm going to come back up here to my original page. Zero's in the middle, -2/3 is somewhere over here. I'm not really concerned if it's to scale, just relative to 0. And then 2 is over here. Because the symbol is less than, we're going to go between those two spots. And there's no line, so we'll use parentheses. They're always going to face each other for less than and go between. So it's between -2/3 and 2. That's a distance that is less than the given value. So less than goes between. Again, think about being less than 5 miles from home. That means you're close to home. You're between those 5 miles. So inside. So that's less than. Again, you treat it like an equation. Get your two spots, and your interval is between those two spots. Let's kind of talk about the same idea for greater than. You might want to get to a clean page for this. We're going to set up, take some notes about greater than, and then we'll set up that same 3-column format. So let's talk about greater than. This will be on an EX page on your notes. So this is when the absolute value of the expression is greater than some number, or it could be greater than or equal to some number. It doesn't matter as long as that number is positive. All right, so for greater than, if you think about the distance, and again your book does a good job explaining this, if I have a little number line, and here's kind of my home base, here's kind of two border points, I'm going to call them A and B, and I want to be greater than a certain distance. So if I want to be at least 5 miles from home, or greater than 5 miles from home, it goes away from those two spots. So greater than absolute value inequalities, greater than absolute value inequalities are away from the two possibilities, the two what I call spots. I don't think they're mathematically called spots, but that's kind of how I think about it. But greater than absolute value inequalities are away from two spots. The intervals are outside of the two values. So think of greater than is you're trying to get away from something. You're trying to get away from those two spots. It is outside of those two values. So instead of being close to, like less than, you're greater than, you're away from those two spots. So let's go through. We're going to use the same 3 examples, but we're going to do greater than instead of less than. So if you want to make that same kind of 3-column format, we have the inequality, the graph, and the interval. And that could be more than one for greater than, so intervals. So the inequality, the graph, and the intervals. So we're going to go back and look at example 1, except we're going to call it example 4. The absolute value of x, this time it's going to be greater than 5. So we still have those 2 spots on the graph. So just like we did for less than, let me bring less than back over. Just like we did for less than, x could be -5 or +5. So we're going to make that same number line with those 2 spots, -5 and +5. So 0 could be +5 or it could be -5. But this time, from these 2 spots, we're going to go away, or opposite directions. So we're going to go away from each other. They kind of push out. So if you want your distance to be at least 5 miles from home, you're going to be 5 miles in one direction away or more, 5 miles in the other direction or further away. So positive infinity to negative infinity is involved in these. So your interval is a union of 2. We have negative infinity to -5, union +5 to infinity. So we use that u like we did for or, where we have that broken interval pushing away. Same thing if we have something to solve. So example 5 is going to look just like example 2, except it's going to say greater than. So the absolute value of 2x plus 1 is now going to be greater than or equal to 7. So again, it's the same values, but instead of less than or equal to, it's going to say greater than or equal to. So you have to pay very careful attention to which one it's facing, which direction it's facing. So we already solved this. I'm not going to solve it again. When we solved this, back on example 2, we got -4 and 3 as our 2 spots. And we're going to keep those same 2 spots for this example, -4 and 3. The difference is from these 2 spots, we're going to go opposite directions. So we're going to use a bracket at 3 and go away from the middle, and a bracket at 4 and go away from the middle. So one pushes towards negative infinity, one pushes towards positive infinity. Again, if you're saying you need to be greater than a certain distance away. So negative infinity to -4, union 3 to infinity. And I'm using brackets because there's that line underneath. So one more time with example 6. Again, we're going to use the same numbers as example 3. The absolute value of 3x minus 2 plus 5. This time it's going to be greater than 9. So the algebra is the same. Let me show you how we did it before. We have our 2 options, just like before. We move that 5 to the other side. We split it into the positive and the negative option, and we go ahead and solve for x. So we're going to get those same 2 values on the number line. So on our number line, we get the same numbers. It was -2/3 and +2. But from those 2 spots, the parentheses face out and go out. One goes towards negative infinity and one goes out towards positive infinity. So anytime it's greater than, it pushes out. There's a gap in the middle. So this is negative infinity to negative 2/3 with the parentheses, union, another parentheses, 2 to infinity. So greater than intervals are always outside of 2 values. So that's basically it. Not a big deal. We won't really see this again for the rest of the course, but I wanted to make sure to cover it for when you get to college algebra. The last thing I want to briefly mention here are some special cases. And again, not a big deal. I just want to point them out. I want to look at if the absolute value of the expression is less than or equal to a negative value. If you have a negative constant on the other side, then it cannot be less than a negative. The absolute value of anything is either 0 or positive. Those are the only two options. Whatever's in here, when you take the absolute value, it has to be a positive number. So this is never true. So anytime you have the absolute value of an expression is less than a negative, it can't happen. Never true, no solution. The other special case is if you have the absolute value of an expression. Again, make sure your notes are clear where they look like absolute value bars. If you have the absolute value of an expression is greater than or equal to a negative. If it's greater, then again, if you always get 0 or a positive number, once you take the absolute value, this is always true. So that's the all real numbers. Negative infinity to positive infinity. So again, if you have a negative on the other side, if it's less than or equal to the negative, it's never true. If it's greater than or equal to a negative, it's always true. So that's the special cases about negative k values. They use the letter k to represent the number that's by itself on the other side. So if you get into those situations, they're either never true or always true. All right, so you should be able to complete that last homework. Remember, it's not due until before the final. You just need to complete these notes before the final, because there will be a question or two over this on the final exam.